So talking about, if you're looking at entropy and you're looking at this formula, right? Notice that, okay, that heat flow, you have to have heat flow in order to have a change in entropy, okay? So if you have an adiabatic process, there is no heat flow, and the numerator of this thing is zero. So therefore, you have no change in entropy. So adiabatic processes have no net change in entropy, okay? If you have an isothermal process, okay, let's say we have a cylinder and we isothermally compress it, right? Which, yeah, you might ask yourself, how could you possibly compress a gas and not change its temperature? Well, you do it very, very slowly. Okay, so it's not really practical. You really can't compress a gas isothermally. It's just you can't do it. But let's imagine that we do it, right? We put one grain of sand on there. And we have this surrounded. It's made of silver, so it conducts heat very, very well, and we add one grain of sand per 5 minutes or something like that, and just slowly compress this thing, right? Heat is going to flow out, right? And this change in Q over that temperature, right? This is going to be a positive that, right? And then this will be a negative that, right? But the temperatures will be the same, the heat will be the same, and so they will cancel each other out. So for an isothermal process, since Q and Q are the same, since it's isothermal, it's the same temperature, T will be the same, right? And if those are equal and T is equal, then the net change in entropy is zero, okay? So, in short, if you want to compress a gas isothermally, it has to be a process that takes an infinite amount of time, okay? As the time it takes to do it approaches infinity, it will approach isothermal. So it's not a real process. Adiabatic processes, though, I mean, you can just do it very, very quickly. Essentially, no heat flows. So it's actually fairly easy to do a semi-adiabatic process. Okay, so since the Carnot cycle is comprised of isothermal and adiabatic processes, it does not increase the entropy. It cannot increase the entropy. Okay, in theory, right? Real processes do. All cyclical heat engines increase entropy. But if we're actually talking about a Carnot cycle and actually theoretically talking about isothermal and adiabatic processes, our net change in entropy is zero for that, right? Which doesn't violate the second law. The second law simply says that natural processes cause zero change or an increase in the entropy.